Okay, so now we're going to try another similar problem, but this time instead of being given a point, we're told that theta lies on the line 3x plus y equals 0 for x values less than 0. Okay, so we could graph this line, and we've got to pay attention to this restriction right here because we don't want the whole line. We have to have just the terminal side of theta, so it's only going to be on one half of the line. We're going to have negative x values. So we could graph that line, but it's still not going to help us find the trig values. Okay, so what we want to do here, we are going to graph the line, but we're going to find a point that's on this line. And it can be any point that's on that line, because remember we have the similar triangles, they all work out the same. So you can pick any value for x that you want, as long as it meets this restriction right here. We've got to make sure we're on the right side of the line. So we can pick any x value we want. Pretty much anything's going to work in here well. Remember, you want to pick an x value that's probably not going to give you fractions because that's going to be a mess. So let's do x is equal to -1. That should work fine. And that's going to give us that y is equal to +3. Okay, so when we plug in -1, we get a y value of +3. So that gives us a point that's on that line. So -1 and +3. Okay, so that's our point, and that means that's our terminal side of theta right there. All right, so we can go ahead and set up our triangle. This would be -1. This would be +3. We need to find our r, so all of this from here works the same way as we did before, now that we've got a point that's on that line. Okay, if you had chosen -2, then you would have gotten +6, and in the end you would have gotten everything the same as us. So if you want, you can try that on your own. Try plugging in -2, getting +6, and then see what you get for all your values. Okay, so let's figure out r. We've got x squared plus y squared equals r squared. So -1 squared and 3 squared equals r squared. So this is going to give us 1 plus 9 is 10. And then remember, we want to take the positive square root, so we get square root of 10 is equal to r, and that doesn't reduce. Okay, so square root of 10 is our r. And then we do all of our trig values now from there. So we've got sine theta, cosine theta, tangent theta, cosecant, secant, and cotangent. Alright, so starting with sine, remember sine is y over r, or opposite over hypotenuse, so that's going to be 3 over the square root of 10. Okay, we want to rationalize that. So that's going to put the square root of 10 on top. So we're going to have 3 square root of 10 over 10. That doesn't reduce, so we're done there. Okay, and remember our signs. Make sure that they're working out. A, S, T, C. Okay, sign should be positive, and it is. So we're in good shape here. We've got our signs right. All right, looking at cosine, that's going to be -1 over square root of 10. So when we rationalize that, 1 times square root of 10 is just square root of 10 over 10. Don't lose that negative. So we got negative square root of 10 over 10. That looks good. And then tangent is going to be 3 over -1. And so our tangent's going to be -3. Okay, so there's our first 3 values, and then of course the next 3 are just the reciprocals here. So cosecant is the reciprocal of sine. I'm going to flip the first version that I had here and get square root of 10 over 3, because then I don't have to do anything with it. Cosine is going to be the reciprocal here, square root of 10 over 1. And of course that 1's not doing anything, so that would just be negative square root of 10. And then cotangent is going to be the reciprocal of tangent, and that's going to give us -1/3. Okay, so there's our 6 trig values. Just be careful on the simplifying and finding the reciprocals. Okay, so there's all of our answers there.